बेटा तुम जाओ यहाँ से, मेरी क्लास शुरू हो गई है। जल्दी जाओ, दरवाजा देर से लगा देना। मेरे लिए मम्मा कहना पानी भेजेगी। ठीक है। नहीं, गुडवाई तो नहीं है। नहीं बेटा। क्या? जाओ उधर पानी थोड़ा सा दे दो। हेलो। हेलो एवरीवन। इज इट ऑडिबल टू ऑल ऑफ यू? हेलो।
Yes, sir. Audible and visible, sir.
ओके सर, थैंक यू। हेलो एवरीवन, आई एम डॉक्टर सुनील कुमार श्रीवास्तव and today is the 11th lecture of this program, Basic Mathematics. And in this lecture, we are going to discuss the most important statistical topic, that is the correlations. Before going to start the session, we have to follow this, we have to take a general guidelines of this live interactive sessions. And before going to start, all of you familiar with this general guidelines, you have to maintain the discipline for the smooth conduction of the interactive live sessions. You have to type your name, enrollment number, and program name in the chat box to mark your attendance purpose. You have to raise questions only after the completion of the sessions. Avoid posting any invalid questions. Do not start personal conversations. Interaction of the faculty should be constructive. No destructive comment is appreciated. And if you feel any issues, any queries, you may contact on the given academic support services. You may also post your queries to the given IMS_schedule@bgp.ac.in. So that these are the general guidelines. And before going to start the session, we have to first know what is the learning outcomes of this session. What we gain after reading this session. So first of all, we have to know what is the meaning of correlation. So briefly we explain. the basics of correlation. After that, we compute the degree of correlation, relationship between the two variables, that will be linear or multiple regression types. And finally, we analyze the correlation coefficient with the help of the correlation coefficients of correlations. We discuss the method to determine the correlation between the two variables. One of the method is the correlation coefficients of correlations. Other is the Spearman rank of correlations. These are used to discuss the correlation between the two variables for the linear regression purpose. If the multiple regression is going to be happen, so this topic is in beyond the scope of this our syllabus. You may read in our next higher classes what is the multiple regression and so on. So here we are going to discuss only the regressions, linear correlations from the purpose. So first of all, what is the meaning of correlations? Its a definition defines here correlation means it's a relation between two. Definition correlation, if we read these relations, it depends by the relation and defined by the co. So relation between co means two, relation means relation. The relation between the two things. If there are two things, how they are correlated? Suppose we have two variables, like one variable is here demand, and other variable is supply. Suppose two variables that. And suppose yeah, we can also take the price of one things. Price is one variables and supply is other variables. How these two variables are related to each other? Suppose you are going to market and if a supply of one particular thing is too much, then price of the particular things will be the decreased. Price of the situation will be the decreased. And the same thing is reverse with that. Supply of the particular thing is very, very less and demand is high, then price will be also increased in that case. Okay. You increases, your age is increases, like that. Any variables should correlate between the variables. Instead of one effect to give the effect of the other variables. So this type of relation will be known as the correlations. So when the variables, one variable will change in specific change in one variable, give a specific change in other variables, then we say that here the variables are correlated. And the relationship between these two variables is known as the correlations. So that is the relation here. We are going to define correlation analysis statistical techniques that is used to measure the degree of to the two variables which are going to related here. It measures the directions and intensity of the relationship between the variables. So correlation is especially meaning is that here when one variable is related to the another variables, then this relationship is known as the then we say that the variables are correlated and the relationship between these two variables is known as the correlations. So by the correlations, we are going to discuss what is the degree of intensity and how the variables are related to each other strongly, lower, poorer, and so on. And no correlation between them is going to be discussed here. So different type of data is going to be here. We have the different type of data is here. That is the analytical data and cumulative data. So we have the different method to describe the things. First of all, we are going to discuss its kinds. What is the meaning of kinds? When written is here, when variable value of one variable increases correspond to the increase in the other variables, then variable correlation is said to be the positive. Meaning is that suppose we have two variable x and other variable is y. If we change in, if we increase the variable x, if we increase the variable x, so y should also be increased. Okay. And if we decrease the variable x, y the variable also should be the decreased. So this type of correlation known as the positive. This type of correlation known as the positive correlations. What example of that one? One variable increases, other variable also going to be increases. When decreases, other variable going to also be the decreases. You may think any type of example of your daily routine of your life. You can think this is just how we discuss the concept of demand and supply here. And this type of also you can say the directly proportional relation, you can say that. Okay. We are reading the other concept of is that P is proportional to P is here and so on. So different is that if other thing is that if decrease in one variable correspond to decrease in other variables. So it should be the negative. If we increase one variable, there should decrease in other variables. So suppose variable is x is there. If we increase the variable, another variable is y. If we decrease this variable, then this type of the correlation between this type of two variables is shown to be the negative correlations. That is known as the negative correlations. And if there is no relation between the two variables, then they are said to be the independent or uncorrelated. Uncorrelated means in other ways we can say that there is no correlation between these two variables. There are no, in fact, change in one variable does not give any effect to the change in the other variables. So here I have discussed three types of specific variables. We have the two variables in such way that change in one variable give the specific change in the other variable in the same direction. Same direction means if increase we have increase in the one variable, there should be also increase in the other variables. Or we have decreased the one variables, there should be specific decrease in the other variables. And this type of correlations is said to be the positive correlations. And if increase in one variable, there should be decrease in other variables. Decrease in the other variables. If increase in one, there will decrease in other variables. And if decrease the one variable, it will increase in the other variables. This variable is said to be the negative correlations. And there is no specific change. If you change the other variable, there is no change of in the other variables. That is said to be that no correlation exists between the two variables except one. So here we have the different kinds of scenarios given here. Okay. Now, in the case of the distribution could be defined in the two types. One is the univariate distributions. A distributions which has only one variables. For example, height of the student of a class, marks obtained by the student in the class. So this type of distribution is known as a univariate. And this is the y-variate. There is distribution have the two variables. Suppose we are going to discuss the student of a class, height and weight. Height and weight of the particular student of the class. So this type of distribution will be known as the one variable x, the other variable y. There are two variables. This is known as the y-variate data. Y-variate and univariate. So univariate distribution is not here. We are going to not discuss it because we already say if there are two variables such way that they are correlated to each other. When we change in one variable, there is specific change in the other variable. So it will be only discussion for the y-variate distributions, not for univariate. Okay. So y-variate distribution, so there is two variables. If you change in x, there should be a specific change in the y. We can say variables are correlated and relation between them is known as the correlations. Okay. If we give the increase in the variable x, there should be specific increase in the variable y, or we can decrease the variable x, there is specific decrease in the variable y, then correlation is said to be the positive. Okay. If the increase in the x variable, there should be decrease in the y variables. If we decrease the y variable, there should be increase in the other y variables, then correlation is said to be the negative correlations. If we change an variable x, no change in the variable of y, this is should be the zero correlation and no correlations. So we have to first of clear concept is that we are going to discuss only for the y-variate distribution, y-variate data, in which a distribution has two variables. Distribution has two variables. Just for example, marks, rank, height, weight, and so on. This will be the distribution of data in this way. Now, before define the definition of correlation coefficient, how to measure them and what is the property of the correlation, we have to know the concept of covariance. In our previous lectures of the statistical portion, we have discussed with you the standard deviation, covariance, and so on. Once again, I'm going to repeat you because next formula that's going to read here depends upon only on the covariance here. So first of all, we have to know what is the meaning of covariance. It is the calculate the directional relationship among the two variations. Directional relationship matlab with increase, there should be the specific direction of increase or decrease there. We should be the discussed. So it discussed here directional relationship between the variables. Now the covariance between the two variables x and y is denoted by covariance of variable x and y, that is covariance of x and y. If corresponding values of x and y are given in the ordered pair form x1 comma y1, x2 comma y2, x3 comma y3, xn comma y1, then covariance is defined in the form x1 minus of x bar, y1 minus of y bar plus x2 minus of x bar, y2 minus y bar plus xn minus x bar plus yn minus of y bar upon total number of terms. X bar is the mean of the distribution, X series, and Y bar is the mean of the Y series distributions. So it can also written the summation form is here, covariance of X and Y for the ordered pair of values x1 comma y1 to x1 comma yn is given by the expression of here 1 by n, summation of n is equal to 1 to infinite xn minus x bar, yn minus of y bar. If we solve this expression in the terms of this one, if we multiply the summation xn minus xn yn, as it's simply that xn yn, and summation is taken that there is summation, that's expectation value of x and y, and summation value of expectation of x and expectation of y. So it can be also written in the form, it can also written in this form. We have to need only one formula method that you follow, and you can easily remember that. Not you have to learn all the formulas. You have to just follow one formula, and that's use the formula for all the questions. And every questions of the correlations will be solved by them in a very easy way. So this is the formula is also applicable. This is the generalization method. This is our summation method form, and this is the transformation method in the form of the expectation value of the variables. So EXY, expectation of x, expectation of y, are the corresponding means. The covariance formula is also can be written in the form is here also written in the form. Covariance of xy is equal to summation of xy upon n, summation of x upon n, summation of y upon n. It can also be written in this form. It can also be written in this form. So these are three formulas, almost four formulas given here, and you may consider any one of them for solving purpose of your problems. You may consider any one of them for solving purpose of your publication problem solving. Okay, this is the formula about the covariance. Now moving further to the next, we have taken an example to describe the covariance of the two variables. We have taken an example here to describe the questions. Find the covariance of the following pair of observation of two variates. One pair is that x1 comma y1, x2 comma y2, x3 comma y3, x4 comma y4, x5 comma y5, x6 comma y6, x7 comma y7, y8 comma y8, x9 comma y9, and x10 comma y10. So number of terms here, x is equal, number of is equal to n is equal to 10 here. First of all, we what have to do? We know the formula to describe it, to find the correlation between the variables. We have to know the formula, that is the x1 minus of x bar into y1 minus of y bar. So first of all, we have to find the mean of the variables. And to find the mean, we have to know the summation of x and summation of y. So calculating the sum of xi series. Okay. The sum of x is equal to here 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. That is 10, 15, 20, 25, 30, 35, 40, 45, 50, and 55. And that is equal to the 325. Similarly, calculating the sum of y series also we can find out here. That is the y1, y2, y3, y4, y5, y6, y7, y8, y9, and y10. That is the 35, 20, 30, 30, and so on 70, and is equal to the 370. So first of all, we have to just find summation of x and summation of y. Why we are going to find this one? Because we have to find the mean x bar and y bar. Okay. Now calculating the sum. Now we have to calculating the sum of xy because we have also the formula. In the formula we have the summation of x, right? What I have to do? This is the x and this is the y. We have to multiply 10 into 35. Okay. 10 into 35 plus next 15 into 20 next pair, 20 into 30 next pair plus 25 into 30 next pair, 30 into 35 that is the next pair, 35 into 38 next pair, 40 into 42 next pair, 50 into 45 next pair, and so on. And after multiplication and simplification, we have the sum of this one 350 plus 300 plus 600 and 750, 1050, 1330, and so on. And finally, we have to calculate the sum. Finally, we have to calculate the sum here. Sum is given by here 1300 and 13,260. That is. So what is the formula? We are to go to find the covariance formula, and covariance is given by covariance of xy is given by summation of xy upon n minus summation of x by n summation of y by n. So summation of xy is given 13260 and number of n is equal to 10 is here. And 325 upon 10, 375 upon 10. After making the calculation, we have the value 123.5. This is the answer for that one. Just we have to use the values, simplify the things, and make the calculations. No formula and no other basic calculations are going to be needed here. Just you have to read the formula, make the simplification like for the as requirement of the formula, and simple calculation give your answer. So this is the very good topic, and just we have to understand how to calculate. Just we have to understand how to calculate. I think you have all of you have understand this one, how to calculate the covariance of two variables. Okay. Now we move some properties of the covariance. Correlation coefficient. What is the coefficient? Correlation coefficient between, already we have discussed, we have the two variable x and y. Okay. The degree of correlation, relation between how to numerically measure. So we have to use the concept that is denoted by the R, and that R is known as the correlation coefficient. That is known as the correlation coefficients, yeah, correlation index. It is usually denoted by the small letter R. What is the R? It denotes the correlation between the variables A and B. It denotes the correlation between x, the variable x and y. It can simply denoted by the letter R. It can be denoted between the variables also, x, y, and a, b, and r simply can be also used. So the correlation measure in the terms of correlation coefficient. The value of R describe how the bonding or correlation between the two variables is strong, weak, no, and so on. Just in this property and this set, we are going to discuss with you. This is the properties, okay? First, we have to know the values of the correlation coefficients are always lie between -1 to +1, including the same -1 +1. There's a -1 to +1. The coefficient values always equal to -1 to +1. Okay. If correlation coefficient values r is equal to +1, suppose we are going to discuss a problem relation between the correlation coefficient between the variables and find the value of r is equal to +1. So what is the meaning of this? What is the conclusion is find out here? That is the correlation. Correlation, the perfect positive. That is the known as the perfect positive correlation. Bonding is too much strong in that. Okay. If correlation between the variables is lie between 0 to 1, lie between 0 to 1, so that is the case of the correlation is the positive. That is the correlation of the case is here positive. If r is value of r is very nearer to the +1, very nearer to the 1, that is known as strongly correlation. Meaning, suppose we are going to the value of r is equal to 0.95. Suppose for solving a problem, we get the value of r is equal to 0.95. What is the mean? What is explaining this one? this is the correlation is strongly positive. Strongly positive. Correlation is strongly positive. And the same concept for when R is negative. When R have the values -1. If R is equal to -1, then correlation is perfect negative. If R is equal to +1, correlation is perfect positive. If R is equal to -1, correlation is the perfect negative. If the value of R is very, very close to the -1, then correlation is strongly negative. That is, correlation is strongly negative. If the correlation value lie between -1 to 0, then correlation is negative. It lie between 0 to 1, correlation is positive. If value of R is equal to 0, no correlation exists between the variables. If R is equal to 0, there is no correlation exists between the variables. And if R is close to the 0, then correlation is very, very weak. Then correlation is very, very weak. R is very, very -1, correlation strongly negative or strongly positive. And R have the value, suppose R have the value 0.1 or 0.05. So this is the very weak correlation existence between the variables. So this is the things. Now moving further, we have to describe the methods to describe how to find out the correlation coefficient between the variables. So first we have to describe the method in two categories. One is the graphical method. One is the graphical method. And in the graphical method, we can describe the scatter diagram method and the correlation. Suppose we are going to discuss a graph here and plot the pair of points in that set here. The pair of points are very, very dense. On the basis of that, we can describe the correlation coefficients nature between the variables. If the points are very, very variables, you make a straight line, you make a linear form and so on. So on the basis of the graph designing, you can describe the correlation existent between the variables. So that is the same things for the correlation graph and the scatter diagram. And the graphical methods can be also be used to find out the correlation coefficient between the variables. And the other classification is the analytical method, that is the analytical methods. And in that category, we have the 4 different way to find out the correlation coefficient between the variables. And one of them is here, Curl-Pearson coefficients of correlations. Other is the Spearman rank of correlations. Other has the concurrent deviation methods and two-way frequency table methods. Here in this lecture, we are going to discuss the Curl-Pearson coefficients of correlations where data is given in numerical forms. When we are going to discuss here Spearman rank of correlation, where data is given the cumulative form, meaning is that where data cannot be measured in the numeric form. Suppose we are going to discuss the beauty of going to discuss the correlation existence between the beauty of two girls. So how to describe, how to give the measurement of that one? So here we cannot use the cumulative data. Here we can use the not the numerical data. Here we are going to use a cumulative data. And here we discuss the method transformation in the terms of their ranking form. Ranking form. So this method is also known as Spearman rank of correlation. First of all, we have to give the rank. Then we take the deviations, and after that apply the formula for the ranks. So this is the another method, completely method we're going to discuss in that context, how to describe and how to this relate with the relation regression analysis with the concept. So these two methods are very much important here to describe the correlation coefficients of correlation to find out the correlation between the two variables. Another one method is the Spearman rank of correlations between the two variables x and y. So one by one, we have to discuss here. First of all, we are going to discuss what is the Kerr-Pearson coefficient of correlations. That is the Kerr-Pearson coefficient of correlation, also known as the Pearson's correlations, describe the linear relationship among the two quantitative variables, where the variables are given in the terms of quantitative, not qualitative. That is the quantitative data is given. So therefore, the assumption should be required. Both variables are an interval or ratio level of measurements. Data from the both variables follow the normal distributions. Normal distribution data can be lie between in the terms of the minus infinite to the plus infinite and symmetrically distributed about its mean. So this is the follow the normal distribution. Okay. And the linear relationship between the two variables would be the existence. So that case in that we apply here the method of Kerr-Pearson coefficient of correlations. The method is very, very easy. And all of you familiarize with the concept of all the related terminology of that one. So don't worry how to use and how to calculate the formula. First, you just follow the instructions. That's what I'm giving you. Okay. If any of these instructions are violated, we consider the rank correlations. So that's we are going to just discuss with you. We have to first find the qualitative data. We have to measure the quantitative data. We have to use the Kerr-Pearson coefficient of correlations, and qualitative data we have to measure the Spearman rank of correlations. So here we can decide on the basis of these assumptions that were discussed here. If these assumptions are not followed, any one of them, then it can be solved the problem by the use of the rank correlation. That is the Spearman rank of correlations. So it is given here. Now, the covariance and standard deviation of two variables are, if you know, then correlation between the Kerr-Pearson coefficient given by the formula, that is the covariance of xy upon sigma x and sigma y. What is the sigma x? Sigma x is the standard deviation of x values. Sigma x is the standard deviation of x values. And sigma y is the standard deviation of y values. And x, capital X means division division from the mean x minus x bar, and y division from the mean y bar. That is the covariance given by the summation of x minus x bar into y minus y bar upon n. And sigma x have the formula that is given by under root sigma x minus x bar whole square by n. And sigma y is equal to sigma of summation of y minus y bar whole square by n. That is summation standard deviation of x value and standard deviation of y values. The above formula is applicable when the covariance and deviation of corresponding variables are given. And this method is also known as the covariance method to calculate the correlation coefficients. So just we have to use the formula, that is this one. For the covariance, we have to use this formula. For standard deviation of x value, we have to use this formula, and standard y have to use this formula. And after calculating all this one, we have to put here and find the correlation coefficient between the variables x and y by the use of the method that is the Kerr-Pearson coefficient of correlations. So we take an example and describe the things one by one. Okay. And substituting the value of the standard deviation of x series and y series, the formula can be changed in also in this form. R is equal to summation of xy upon summation x square summation of y. So this is the summarized form. X means division from the mean, y is mean division from the mean. And after putting all these one, we can also summarize in this form. This formula also can be used to find out the value of correlation coefficient by the calculation. That is given by n summation of xy minus summation of x summation of y upon n summation of x square minus summation of x whole square, n summation of y square minus summation of y square. And one method is also here that is much more useful to describe the things. And that is the not you have to use this one. Always remember to you, always to given the instruction to you to use this one formula here, not that formula. You can be usually that is will be very much easy to find the things. Okay, so just to find the deviations, find the sum. Just we series the standard deviation of x series and the standard deviation of y series and put the value just here and find the answer. So I think my personal views, you have to use this one and to find the answer, not this one. It will be more difficult to you, but you easy way you can also task if you are going to use this one, you may find the answer. But I think this is the too much difficult. Next, what is the working rule to find the mean deviation for a group data and from the mean? Also discussed in our earlier classes with how to calculate the mean deviation, but one I am going to also revise with you. No, there should be no confusion like that. We are going to solve the problems. We have to feel the things. Okay. So first of all, whatever you do, you use the find the mean by using the formulas. Total frequency upon total number of frequencies. Frequencies. We have to use the formula by direct method. Then find the deviation x bar, that is xi minus x bar, and find its absolute values. And then multiply the frequency, take the sum, and divide the total number of frequencies. So this formula can also be used to describe the standard mean deviation from the group mean data and can be used to find out the things. And one shortcut method is also have to discuss here to describe by using the step deviation method. Okay. Here, this method is also given here, but using purpose, this method is going to be much more complex here. So just I have discussed with you earlier by the definition purpose of the method, just you have to follow for any purpose of calculations or finding the answer of any problems. So that will be too much easy to all of you. Not this method is going to be used. If especially indicated in your problems, you have to use this method. Then you apply, otherwise you are also too free to do the things. Okay. So sometimes the direct method becomes very tedious and lengthy. The mean of two series is not integer. So we can case we minimize the times and calculations to assumed arbitrary points by the given assumed method, and we calculate the deviation dx and dy for each of the x series and y series. So in that case, formula to obtain the correlation coefficient by the step deviation method is given by the expression that is r is equal to n summation of dx and dy. What is the dx? Dx is the division from the x series and dy the division for the y series. Okay. Minus summation of dx summation of dy upon n summation of dx square minus summation of dx whole square under root n summation of dy square minus summation of dy whole square. Where what is the meaning of di? Dx, di is given by the division from its assumed mean divided by the size of the interval. That is size of the interval. And the same thing also going to be used for the dy, divide the y minus b, that is the assumed mean for the y series, divided by the k is the size of the y series interval. This formula can also be used here. And h and k are common factor of x series and y series respectively here. That is the what is the difference between them is going to be given. So x have the value 2 equals x, h have the value for difference of any two successive terms. So this is the method and have to use the things. Now we have taken example to describe the things in very detailed way. And we have the problem is that suppose psychological test of intelligence and computer skills. One, psychological test of intelligence, that is the variable V, and computer skill is the variable B. With when applied to the 10 student, number of students is equal to 10. The following is the record of ungrouped data showing the intelligence and computer skills. Calculate the correlation coefficients value. So what is given is student A, B, C to J. Student A, student B. Its intelligence ratio is given here, and computer skills ratio is also given here. So A have the student A have the intelligence ratio relation that is given by 105, and computer skills ratio is given as 101, and for the same thing also given for the all the 10 students A to Z, that is a 92 upon 94 and so on. And for this data we are going to discuss how to calculate the coefficients of correlation between the variables and how to calculate. So first of all, my opinions my opinions before preparing the tables we have to write the formula. First of all, what I have to do before preparing the table, we have to write the formula. Yeah. So before preparing the table, we have to write the formula. So first of all, given is students, that is the E to Z is given also. And one variable is X, that is given by the IR, and the other is the CSR, that is the computer skill ratio. These are given here. So first of all, we have to take the division X minus X bar. Well, first of all, we have to find the mean of X series. Okay. So accessories gain 105, 104, 102, 101, 199, 98, 96, 92. And total sum is here 990. And total number of student is here 10. So X bar will be here 99. So division will be here, find out. Division will find out here. So we construct the following table as the correlation coefficient purpose. Hello. I think the system is hanged here. Wait 1 minute, sir. Na? All of you. Wait 1 minute. Mm. Hello. I think some system is hanged here, so unable to do anything. So until wait for. Hmm. I have some problems. So we are just discussing here how to calculate the things to discuss. Here we have to just follow the instructions like that. What I have to do here, there are two variables is given here, x and y here. So I try to do the things, but unable to do many things. System is going to be hanged like that, unable to understand what is happening. So I think I have to wait for 2 minutes. Just unable to do anything in our PPT presentations. It's going to be hanged here and not doing anything. Not closed, not open also. I think you have to see in the So there is some problems was given. And just we are going to discuss is here, that is what the topic was, that we are going to discuss, we are discussing here the problem of that. So just what happening is here. Problem is happening. So just we have to find a deviation from its mean and x bar and y bar, and find the values of x square, y square, and the summation of x y series. And just multiply that the x square, suppose x is the 6, the x square is the 36, y is a 3, y square is a 9, and then multiplication is a 18. We have to do for all the columns and take the sum of this. And just using the formula is here, summation of coefficient variables given by the expression r is equal to sum of x y upon summation of x square upon summation of y square. And the value is given by 0.5. It is the expression can be given like that by using this one method. Another method was that correlation of coefficient by the grouping of data. And in that category, we have just going to discuss with you that the Spearman rank of correlations, rank correlation of the things. And the rank correlation was developed by the British psychologist Carl Spearman in 1904. In this method, various items are assigned to the rank correlations by their specially giving to the highest marking to the first ranks in the basis of that one. So correlation coefficients and the rank correlations coefficients have the same interpretations, but the definition of the calculation, when Spearman rank of correlations formula has been derived from the simplifying correlation coefficients, where the individual values have been replaced by the rare ranks as also. For example, suppose we have a given a formula is here. The formula is given by then the concept of this, and we have to calculate the rank is here. And that is given by r is equal to 1 minus summation of 6d square upon n square minus of 1. This is the formula. And what is the d? D is the deviation from its differences in the rank of the both the series. Suppose if x series have the rank and y have the series rank, so d is the given by the dxi minus of dyj. That's it. So we have the differences in the ranks. How to give the rank, that is the most important is here. Here table is in that case, marks is given by the some student, that is given by here, and 52, 53, and 42, and so on. And here we have the given the 65, 65, and so on. How to, first of all, we have to give the rank. How to give the rank? We have to give the first rank to the first highest value. So in X series, we see the highest value, that is the 60. And he had a 60 value, and you think that this is a value is given is a 1. Rank is given is a 1. Okay. And in the same things, in the lower, that is the below the things. So from 60, lower value is here 53, and this rank is here 2. And the same 53 lower, that is the 50, this rank is 3, and so on. And same repetition we have to do for the Y series also. Here we have to take the highest value. Here is given 75. So if we take here this, we find that is the rank is given 1. And then second highest value is given, that is here 73. So rank is here also given 2. Then that way we can give the highest value to the rank 1, lower value to the rank 2, and smallest value to the last rank of the given observations. So we can here find the X ranks and the phi series or Y ranks. And next we calculate the difference of the rankings, that is the R1 minus of R2, that is the dxi minus dy. So 3 minus 3, that is 0. 2 minus 2 is also 0. 5 minus is also minus 1. And take the summation square, d square, and find the solution. That is the d square summation of this is 6 square. And then use the formula r square is equal to 1 minus summation of 6 d square upon n square minus of 1. This is the formula. And putting this formula in these values, you can calculate the rank correlation for the given observations. So here we find the answer, that is given by 0.539. That's also given the values here 0.539 is here. So just put the values. That is the 1 minus 6 summation of d square upon n square minus r. N is the number of terms for the given observations. So here the term is given 10. So that is 1 minus 6 into 76 upon 10 into 10 square minus 9. 1. 10 square minus 100 minus 99. So it will be 1 minus 676 multiplied by 10 into 99. And after making the calculation of this one, we'll find the value of 0.539, and that will give the rank correlation value by the Spearman rank of correlations. So in the correlation concept, we have to give the rank first, and then after we have to analyze the things. So we have to finally come across the learning outcomes. We understand here basic of correlations. What is the meaning of correlation? What is the kinds? What is representation? What the correlation coefficient government discussed? We also discussed here the correlations, how to calculate, what are the properties, and so on. And how, so finally we completed and analyzed the correlation with the help of correlation coefficients of correlation, Spearman rank of correlation we have discussed here. So I think all of you enjoy the sessions. Sometimes we are going to disturb by the hanging of the system. So finally we have to complete the session. And happy learning to all of you. If you have any doubts, you may raise your questions in the chat box. And tomorrow will be the last lecture of the session. So, and topic will be the regressions. So regression, correlations, and fittings and statistical data, all are interconnected topics. You understand the concept of correlation, you will better understanding will be find out in the topic of regression analysis. And that will be the last topic for tomorrow for our learning sessions of this session. Okay, happy learning to all of you. Thank you.